Welcome to this report on automation and robotization in U.S. factories, evolution, impact, and the role of tariffs. This comprehensive overview provides a deep dive into the development and implications of automation within American manufacturing. We'll explore the historical roots, examine the current state as of 2025, and project where the industry is headed. Along the way, we'll look at how automation affects jobs, workforce skills, and the influence of tariffs on reshoring and domestic employment. This analysis brings together research, case studies, and strategic insights from manufacturers, policymakers, and workers navigating a rapidly changing industrial landscape. The journey of automation in the US began with early mechanization. In 1793, Eli Whitney's cotton gin fundamentally transformed labor demands and industrial output. The steam engine, which gained prominence in the 1830s, introduced a new era of mechanized power. By 1890, Herman Hollerith's tabulating machine ushered in early forms of data processing. The 20th century saw monumental shifts. Henry Ford's assembly line revolutionized mass production. And in 1961, General Motors deployed Unimate, the first industrial robot. The introduction of computer-aided design software and programmable logic controllers later accelerated the transition toward flexible and intelligent automation. By 2025, automation has become widespread, particularly in sectors like automotive and electronics manufacturing. Companies implement it to reduce costs, improve quality, address labor shortages, and meet consumer demand for greater customization. Technologies like artificial intelligence, autonomous guided vehicles, collaborative robots, or cobots, and Industry 4.0 systems are deeply integrated into production lines. Corporations such as General Motors, Ford, and Honda showcase some of the most advanced applications of these tools, blending mechanical precision with intelligent decision making. Looking ahead, the future of automation promises even greater transformation. In the rapidly growing electric vehicle industry, digital twins, smart sensors, and real-time analytics are redefining manufacturing. Emerging innovations such as plug-and-produce systems, humanoid robots, and agentic AI will bring new levels of adaptability, responsiveness, and operational efficiency. These technologies are not just about machines doing more. They're about building systems that learn, evolve, and collaborate with human workers. Throughout history, automation has displaced certain jobs, especially routine, low-skill roles, while creating others in design, maintenance, and systems engineering. Today, automation plays a critical role in addressing labor shortages and improving workplace safety, but it also requires workers to reskill and upskill rapidly. As technology advances, routine roles will continue to decline, but the demand for technically skilled labor, such as robot programmers, AI analysts, and systems integrators, will rise significantly. Retraining and workforce adaptation are no longer optional, they're essential. This shift in technology demands a corresponding shift in skills. Expertise in robotics, AI, data analysis, and digital communication is increasingly vital. At the same time, soft skills like critical thinking, problem solving, and effective teamwork are equally important. Competencies such as predictive maintenance and human robot collaboration are emerging as key elements of modern manufacturing roles. Companies and educators alike must prioritize continuous learning to keep pace with change. Meanwhile, tariffs, often aimed at encouraging reshoring and protecting domestic industry, add another layer of complexity. On one hand, tariffs can make foreign labor less competitive, prompting companies to invest in automation as a cost-saving measure. On the other hand, tariffs that raise the cost of imported automation equipment can discourage adoption. The result is a highly nuanced interaction between trade policy and technological investment, where the impact varies widely across industries. This interplay between tariffs and automation also affects employment outcomes. While reshoring might increase domestic production, automation can reduce the number of traditional manufacturing jobs created. However, it also generates new roles that require higher levels of skill. To make this transition equitable and effective, workforce training programs must be aligned with broader trade and industrial strategies. Investing in education and reskilling is vital to ensuring workers are not left behind. From a strategic perspective, manufacturers must adopt a dual focus, investing in automation while building a resilient and skilled workforce. Policymakers must align trade and labor policies to support innovation and employment. Workers themselves must embrace lifelong learning, equipping themselves for a future defined by digital technologies and smart systems. Collaboration among these three groups, industry, government, and labor, will be the cornerstone of success in the automated era. In conclusion, the future of US manufacturing is not solely about machines, it's about people, policy, and strategy working together to shape a resilient, competitive, and inclusive industrial economy. Automation and tariffs, when thoughtfully managed, offer not just challenges, but opportunities to redefine American manufacturing for the 21st century and beyond.